Hi, this is Jonas from WireFlow, and I'm going to demonstrate some of the features of the Lundby Data Logger. The Lundby Data Logger is a distributed and synchronized data logging system. Its main features is that it's distributed, and we say distributed, we mean both in terms of I/O and computing to provide more flexibility. We're using time synchronization to provide time accuracy between nodes, and it's also very scalable since it's distributed. And each node performs local logging to maximize the data throughput and to make it redundant to maximize uptime. So the system we're going to demonstrate today is we have one presentation PC running the Lundby user interface and the Lundby streamer service. The Lundby user interface is responsible for monitoring and configuration of the system, while this Lundby streamer service is responsible for fetching ready log files from all the logger nodes. The presentation PC is connected to a main switch, and the main switch is in turn connected to the different nodes. From the main switch to the nodes, we're using the time-sensitive networking features, especially the IEEE 802.1 AS to get the time synchronization in the system. And the time synchronization, as I said, is based on IEEE 802.1 AS. So the master switch gets an external clock and distributes that as a time sync master in the network. Each logger node has a slave switch, and this is configured to distribute the master clock to the slave devices. That could be other switches in a daisy chain or I nodes. The I nodes, they will get the absolute time from the network and use an internal oscillator for the DAQ tasks. And I should say that the DAQ tasks, they are actually phase locked to the network time, meaning that all DAQ tasks, regardless of which node they are running on, are also time synchronized to the network time. So the first demos we're going to do is we're going to replace a node on the line system. And the scenario is that we have one node that has dropped out of the system due to a malfunctioning component, and we need to replace this. So at this point we have removed the old node from the system, but before the node has been replaced, a logger action affecting all nodes has been started, meaning that we will replace a node on a live system meaning that we are logging data actively. So if we first go into the Lundby system, we currently see only one node on the system, so we need to add a new one. But before that, we simulate that we have a trigger by starting this trigger, demo all channels. So now we have an active logging system. We are running this trigger system on station 0. So let's go into and configure the system and add a new node. So we see that there is an available node on the system that we connected to the network. So what we are going to do, we're going to adopt this system into the node. We're going to name it station 1. I'm going to save that. And we're just going to wait for this station 1 to be connected to the system. Now we see the station 1, we have knowledge of station 1, but it's still yellow, meaning that we have no connection. And what we expect now is the first station 1 to be connected to the main system and the main switch, getting the same time sync as station 0. So we just have to wait a little bit until we get time synchronization. So here we go. The first part is that now we're back in a time sync environment. So what we're going to do now is that we know that this one has backup. So we are going to restore from this backup. And let's go that. I don't want to do a reboot at the moment. I'm going to do this a little bit quicker by doing a software restart instead, just for the sake of the demonstration. So now what we have done is we have added a node. We have added a backup, or actually we have restored it from a backup, and now we just reboot station 1 to get all the configuration from the restoration point. So now we expect again the first station 1 to pick up the time sync from the network, and once the time sync is okay, we expect it to be part of the logging, because the logging session should affect even station 1 at this point. So now we see that station 1 is also actively logging data because of this one here, and we also see that we have 2 running triggers, running nodes at the moment, logging this all channel demo. So if we just abort this trigger now, and let's see what we have in the log folder, we see that this is a triggered log folder. This is all the log files that we have fetched with the streamer service. We see station 0 has a lot of log files, but we also see that station 1 has detected and found that, okay, we have log files that should be active logging that should be active. So that works. So we had a live system. And we added a node, and the other nodes in the system, they continued to log unaffected. And once the node has been replaced and restored, we see that it starts logging as it should.